Hours of most unsettling space discoveries to sleep too. The Void of Boötes. Close your eyes and imagine this. A chasm in the fabric of the universe. A gaping maw of nothingness so vast it could devour 1 billion galaxies without a trace. No stars to guide you. No light to warm you. Just an endless, suffocating void stretching further than the mind can grasp. They call it the Void of Boötes, a cosmic graveyard where creation forgot to tread. But here's the shiver down your spine. It shouldn't exist, and it's growing. Tonight, we're diving into the abyss together. Stay with me, if you dare. It all started in 1981, when astronomer Robert Kirshner aimed his telescope at the constellation Boötes, the herdsman, a quiet patch of sky near the Big Dipper. He was mapping galaxies, plotting their glow against the infinite black, expecting the usual sprawl of cosmic cities. But then, he hit a wall of nothing. Not a dim flicker, not a faint shimmer, just a hole. A super void, 250 million light-years wide, carved out of the universe like someone took a cosmic eraser to the blueprint. This wasn't just a gap, it was a monster. To put it in perspective, our Milky Way galaxy, home to 100 billion stars, spans a measly 100,000 light-years. The Void of Boötes could swallow it 2,500 times over and still have room to spare. Like crossing it would take 250 million years, a journey so long that dinosaurs roamed Earth when it started on the other side. Kirshner's team counted galaxies in that region, where thousands should have sparkled. They found barely 60, scattered like lonely sentinels in a desert of dark. The universe, you see, is supposed to be a web, galaxies strung together by gravity, threaded with gas and dust. Voids exist, sure, but they're small, fleeting. This one, it's an anomaly. Its density is just 10% of the cosmic average, a whisper of matter in a sea of absence. Scientists scratch their heads. How does something this empty just sit there? Now, here's where the shadows deepen. Why does the Void of Boötes exist? The simple answer is chance, a low-density patch from the Big Bang that never filled in. But that feels hollow, doesn't it? A void this size challenges everything we know about how the universe knits itself together. Gravity should have pulled matter in over billions of years, yet this hole stays stubbornly bare. So what's really going on? Some theorists get creative. What if it's a scar? A violent imprint from a collision with another universe. Picture it. Two realities smashing together in the primordial chaos, their edges buckling, leaving a wound of pure nothing. There's no evidence, but the math doesn't say no. Others point to dark energy, that invisible force accelerating the universe's expansion. What if the Void of Boötes is its playground? A testing ground where space itself is stretching thin, unraveling like a frayed thread. Then there's the data. It's growing. Voids expand as the universe does, and this one's no exception. Every year, it widens by millions of miles, swallowing more of the cosmic tapestry. Its temperature's colder too. 7 Kelvin, just a hair above absolute zero, chilled by the fading whispers of the Big Bang. And here's the thought that'll linger. If it's this empty now, what's it hiding? Could something be out there, thriving in the silence? A presence we can't detect because our tools only see light and matter? Or is it a glimpse of the end? A preview of a universe stretched so thin that everything fades to black? The Void of Boötes offers no answers, just echoes in the dark. Telescopes peer in and see nothing but a faint scatter of galaxies, like crumbs on an endless table. Theories swirl, multiverse scars, dark energy ghosts. But the truth slips through our fingers. Maybe it's just a quirk, a hollow note in the symphony of existence. Or maybe it's more, a silent watcher, a cosmic warning etched in absence. So as you drift tonight, imagine it, 250 million light-years of pure, unrelenting void. 1 billion galaxies could vanish inside it, and no one would hear them scream. The Void of Boötes doesn't care if we solve it. It just grows colder, quieter. Sleep tight, or let the darkness keep you company. The Wow Signal, August 15th, 1977. A sleepy night in Ohio. A telescope hums along, listening to the stars, when, boom, a signal blasts through the silence, so loud, so precise, It stops an astronomer dead in his tracks. He grabs a pen, circles it on the printout, and scrawls one word. Wow. For 72 seconds, the universe seemed to shout at us, then went quiet forever. Was it a glitch? A comet? Or, dare we say it, aliens trying to phone home? This is the WOW signal, one of space's creepiest mysteries. Lie back. Let's tune in and see if the cosmos still has something to say. It all went down at the Big Ear, a massive radio telescope sprawled across a grassy field at Ohio State University. Picture it, a hulking dish, 360 feet long, designed to eavesdrop on the universe. It wasn't fancy, just a workhorse built in the 60s to hunt for signs of extraterrestrial intelligence as part of the SETI program. That night, it was scanning the constellation Sagittarius, sweeping the sky in slow arcs, picking up the usual cosmic chatter, static, faint hums, the background noise of creation. Then, at 10:16 p.m., everything changed. The data spiked, a narrow-band emission, sharp, focused, not some random burst. Hit at 1,420 megahertz, the exact frequency of hydrogen, the stuff stars and planets are born from. It was 30 times louder than the cosmic buzz around it, a scream in a whisper. For 72 seconds, it held steady as the telescope's beam tracked it, then faded as Earth's rotation moved the dish away. Jerry Emmon, the astronomer on duty, didn't hear it live. Big Ear just printed numbers on paper, but when he saw the readout days later, he couldn't believe it. The code 6EQUJ5 stared back at him, a peak so wild he circled it in red ink and wrote "Wow" beside it. It was unlike anything the telescope had caught in years. This wasn't just noise. That 1,420 megahertz frequency, it's a cosmic calling card, protected for astronomy, a spot where intelligent life might broadcast if they wanted to be heard. The signal's strength and shape matched what SETI dreamed of finding. Emin and his team checked the equipment, no malfunctions. It wasn't a satellite, a plane, or earthly interference. Something out there had spoken, but only once. So what was it? The simplest answer is a fluke, some natural hiccup we haven't pinned down. But that's where it gets messy. Astronomers have scoured that patch of Sagittarius ever since. Hundreds of follow-ups with bigger, better telescopes, and found nothing. Total silence. If it was a star flaring or a pulsar glitching, why didn't it repeat? Natural signals don't just ghost us like that. And the WOW signal's precision, its tight frequency, its 72-second arc, felt too perfect, too deliberate. Then came the comet theory. In 2017, some researchers said, hey, maybe it was Comet 266P/Christensen passing by, spewing hydrogen gas. Sounds neat, right? Except the comet wasn't spotted back then, and its path didn't quite match Big Ear's aim. Plus, comets don't scream that loud or that sharp. The idea fizzled under scrutiny, leaving us back at square one. So what's left? The big one, aliens. A deliberate ping from a civilization light years away. SETI's been chasing that dream for decades, and this signal checked every box, until it didn't. Why no encore? Did they hang up? Are they waiting for us to call back? Here's the kicker. We can't find it again. That spot in the sky's been dead quiet for 48 years. Was it a one-off transmission caught by dumb luck? A spaceship zipping past, chattering for a moment? Or something weirder, like a signal from a dead world, echoing through the void long after its cinders faded? The more you dig, the more it feels like the universe teased us, then pulled the plug. The WOW signal sits there, a cosmic cold case, taunting us with its 72 seconds of fame. No telescopes caught its twin, no theories locked it down. Maybe it was a fleeting quirk of nature, a radio burp we'll never decode. Or maybe, just maybe, it was a hello from the dark, a whisper from someone, or something that's still out there, listening. We'll never know for sure. Not yet. So as you drift off, imagine that signal riding the waves of space, a lone cry in the night, waiting for an answer that might never come. Sleep well, or wonder what's watching. Oumuamua, alien visitor or cosmic oddity? October 19th, 2017. A telescope in Hawaii catches a flicker, a weird, cigar-shaped thing tearing through our solar system at 196,000 miles per hour. It's red, It's tumbling, and it's not from around here. Scientists name it Oumuamua, Hawaiian for scout, but here's the wild part. It doesn't act like anything we've ever seen. Is it just a rock from another star, or an alien visitor scoping us out? Tonight, we're chasing this cosmic oddball into the dark. Get comfy. This one's a trip. It started with the Pan-STARRS telescope on Maui, a beast designed to spot near-Earth asteroids, rocks that could one day ruin our day. That night, astronomer Rob Warrick was sifting through images when he saw it. A faint moving way too fast. Most asteroids crawl along at 20,000 miles per hour, locked in orbit around the sun. This thing, it was clocking nearly 200,000, screaming in from above the plane of our solar system like it didn't belong. Trajectory math confirmed it. Oumuamua wasn't ours. It was interstellar, the first object we'd ever caught visiting from beyond. Now picture this thing. It's about 800 feet long. Think 3 football fields end to end, but only 115 feet wide. A skinny, elongated freak. It's tumbling end over end every 7 hours, like a cosmic baton gone rogue. Its surface? A deep, rusty red, baked by millions of years of starlight or something stranger. Here's the kicker. It wasn't a comet. No icy tail, no gas jets puffing off it. It wasn't an asteroid either, at least not a normal one. Telescopes watched it zip past the sun, swing by Earth at 26 million miles, and bolt back into the void, all in a few months. By January 2018, it was too faint to track. Scientists lost their minds. An interstellar traveler? That's a once-in-a-lifetime find. But Oumuamua wasn't playing by the rules. It was a puzzle, a reddish, spinning cigar from another star system, barging through like it had somewhere to be. So what is it? The safe bet's a natural object, maybe a chunk of rock blasted off a distant planet by a supernova, drifting for eons until it crashed our party. But then it got weird. As Oumuamua swung past the sun, it sped up, faster than gravity alone could explain. Normally, comets do that. Ice vaporizes, jets push them along. But Oumuamua had no jets, no dust, no signs of outgassing we could see. Something invisible was giving it a boost. Scientists scratched their heads. Was it hydrogen ice we couldn't detect? A fluke of radiation pressure? Or something else? Enter Avi Loeb, a Harvard astrophysicist with a bold idea. He said, what if it's not natural? What if it's a probe, an alien light sail? Think about it. A thin, flat craft, catching sunlight to surf the stars. Oumuamua's shape and acceleration fit the bill. Loeb pointed out its tumble, like it had been abandoned, drifting for millennia. The science community laughed. Aliens? Come on. But no one could fully debunk him. Natural theories stretched thin. Hydrogen ice sounded shaky, and radiation pressure needed perfect conditions. Why was it so quiet, so stealthy? And here's the creepy bit. It came close, closer than Mars at one point, then left without a peep. Was it just passing through, or scoping us out? We only saw it because Pan-STARRS got lucky. How many others have slipped by unnoticed? If it was a scout, who sent it? And why is it silent now, speeding away at 60,000 miles per hour toward Pegasus, too far for us to chase? Oumuamua is gone, a red streak in our rear view, fading into the cosmic night. We'll never catch it. It's outrun our best tech. The safe answer's a weird rock, a cosmic castaway from some shattered star. But that speed up, that shape, that silence, it nags at you, doesn't it? Maybe Loeb's right. Maybe it was a hello we didn't know how to answer. Or maybe it's just the universe reminding us how little we know. As you drift off, picture it tumbling out there, alone in the void, natural oddity or alien ghost. Sleep tight, or wonder who's watching from the stars. Tabby's star and its mysterious dimming. You're stargazing on a clear night, and one star, just one, starts winking at you. Not twinkling, not fading, but dimming wildly, like it's trying to send a message or hi. That's Tabby's star, a cosmic enigma 1,400 light years away that's been freaking out astronomers since 2015. It dips in brightness by up to 22%. Way more than any planet could cause, then snaps back like nothing happened. Is it dust? A stellar glitch? Or something built by someone out there? Let's unpack this celestial weirdo. Lie down, and let the mystery wash over you. It all kicked off with the Kepler Space Telescope, NASA's planet-hunting eye in the sky. From 2009 to 2013, it stared at 150,000 stars, looking for tiny dips in light, the telltale sign of planets crossing their suns. Most stars played nice, predictable blips, maybe 1% dimming if a Jupiter-sized world swung by. Then came KIC 846-2852, Tabby's star, nicknamed after Tabitha Boyajian, the astronomer who first flagged it. This star didn't just dip, it plunged. Picture this. In 2011, it dropped 15% in brightness for days. No pattern, no rhythm. Then, in 2013, it crashed 22%. That's like a fifth of its light vanishing, enough to make you wonder if half the star got swallowed. These weren't clean, periodic dips like a planet's orbit. They were jagged, chaotic, like something messy was drifting in front. Kepler's data showed smaller flickers too, dozens of them, some lasting hours, others weeks, all over the place. By 2015, Boyajian's team published the find, and the internet lit up. A star this erratic? That's not normal. Tabby's star sits in Cygnus, the Swan constellation, a yellow dwarf like our sun, but older, about 7 billion years along. It's stable, no wild flares or tantrums, yet its light's been playing hide-and-seek for over a century. Old photographic plates from the 1800s, dug up later, showed it dimming back then too, by up to 20%. Whatever's messing with it, it's been at it for a while, and it's not stopping. So what's blocking the light? The easy answer's a planet, but no way. Even a gas giant like Jupiter only dims a star by 1%. To hit 22%, you'd need something monstrous, and it'd orbit tight, repeating every few months. Tabby's dips? Random, days apart, then years. Maybe a swarm of comets, then? Picture icy chunks breaking apart, dusting the star with debris. But you'd need hundreds, maybe thousands, all perfectly timed, and even then, the math's shaky. Comets don't block that much light for that long. Here's where it gets fun. Some said, what about a shattered planet? Imagine a world smashed by a collision, its guts spilling into a ring of rubble. Cool idea, but rings are neat, circular. Tabby's dips are sloppy, uneven. Dust clouds? Possible. But why's it been dimming since the 19th century without clearing up? Then, in 2016, a wild card hit the table. Aliens. Jason Wright, an astronomer, floated it. Could this be a Dyson swarm? Picture a civilization wrapping their star in solar panels, a megastructure sipping energy, letting light leak through the cracks. The alien hype exploded. Tabby's star became the most mysterious star in the galaxy. SETI pointed radio dishes at it. No signals. Infrared scopes checked for waste heat. Nothing. Dust came back as the frontrunner by 2018. Observations showed fine particles scattering blue light more than red, a dust signature. But here's the twist. If it's dust, where's it coming from after 100 years? And why no infrared glow from heated grains? Is it really that simple? Or are we missing the signal in the flicker? Tabby's star keeps its secrets close. Today, most bet on dust, maybe from a chewed-up moon or a cosmic pileup we can't see. It's the safe call, the one that fits the data without breaking physics. But that 22% dip, those century-old dims, they nag at you. What if it's not dust? What if something's up there, orbiting in silence, watching us watch it? We might never know. As you drift off, imagine that star winking in the night. A natural fluke, or a lighthouse in the void. Sleep easy, or let the flicker keep you guessing. The Great Attractor. Imagine you're floating in space, weightless, staring at the Milky Way, our galaxy, our home. Now imagine it's moving, and no one knows why. Something out there, hidden in the dark, is pulling us, dragging 600 galaxies, including ours, toward it at 2 million miles per hour. They call it the Great Attractor, a cosmic puppeteer we can't see, can't touch, can't explain. Is it a monster of gravity, or something stranger? Lie back, and let's drift toward the unknown together. It started in the 1980s, when astronomers noticed something odd. Our galaxy, and hundreds around us, weren't just spinning with the universe's expansion like they should. They were veering off course, tugged sideways toward a spot in the constellation Centaurus, 150 million light-years away. Picture the scene. The local group, our little galactic neighborhood, hurtling at 600 kilometers per second, 3 million miles per hour. Toward what? To figure it out, they mapped the motion of 600 galaxies in a region called the Zone of Avoidance, a dusty, star-clogged patch that blocks our view. That's when they named it the Great Attractor. Early guesses pegged it as a massive cluster, maybe 10 quadrillion suns worth of stuff, enough to bend space and yank us in. By 1986, a team dubbed the Seven Samurai, yep, that's what they called themselves, used radio telescopes to peek through the dust. They found galaxy clusters like Norma and Hydra Centaurus, packed with stars and gas, sitting right where the pull was strongest. But here's the snag. Even those clusters weren't big enough. The Great Attractor needed way more mass, like 100 times our Milky Way, to explain the tug. Something was missing. And it's not just us. This thing's dragging a chunk of the universe, hundreds of millions of light-years wide, toward it. We're caught in its grip, and we've been falling for billions of years, a slow-motion plunge into the dark. So what's pulling the strings? The obvious answer is gravity. Some colossal pile of matter we haven't fully mapped. Maybe a supercluster on steroids, stuffed with galaxies, black holes, and gas. The Norma cluster's a contender, 25 million light-years across, brimming with thousands of galaxies. But even it's too weak to account for all that pull. Then there's dark matter, the invisible glue holding the universe together. Could the Great Attractor be a dark matter mountain, 10 times denser than normal, warping space like a hidden giant? It fits. Dark matter doesn't glow, so we'd never see it, but we can't prove it yet. But wait, it gets weirder. In the 90s, astronomers found something beyond the Great Attractor. The Shapley supercluster, 650 million light-years away, with 8,000 galaxies and a mass 10,000 times our Milky Way. Is it the real puppet master, yanking the Great Attractor toward it, and us along for the ride? Some say yes. Others argue the math doesn't add up. The Shapley's too far to dominate. And here's the wild card. What if it's not just mass? What if space-time itself is warped here? A cosmic sinkhole from the Big Bang. A glitch sucking us in. The creepiest part? We can't see it clearly. The Zone of Avoidance, full of Milky Way dust and stars, hides the Great Attractor like a curtain. X-ray and radio scopes catch glimpses. Galaxies swirling inward, gas heating up, but the heart stays cloaked. Are we falling into a natural trap, or something that wants us closer? And what happens when we get there, billions of years from now? The Great Attractor's still a shadow on our maps, a pull we feel but can't pin down. Most bet it's a mix of clusters and dark matter, a gravitational beast doing what gravity does. But that unseen tug, that cosmic curtain, it leaves room for doubt. Maybe it's a relic of creation, silently steering the universe's dance. Or maybe it's waiting, patient, immense, pulling us into a story we're not ready to read. As you drift off, feel that gentle yank, 2 million miles per hour toward the dark. Sleep sound, or let the pull carry you deeper. Pale blue dots, eerie isolation. February 14th, 1990. Valentine's Day. A spacecraft 4 billion miles from home turns its camera back toward Earth and snaps a photo. A tiny, pale blue speck lost in a sea of black. That's us. All of humanity, on what Carl Sagan called the pale blue dot. But here's the shiver. In that vast, empty frame, we look so small, so alone. Is this just a pretty picture, or a quiet scream from the void? Settle in. Let's zoom out and feel the silence together. It all started with Voyager 1, a little probe launched in 1977 to explore the outer planets. By 1990, it had finished its job, Jupiter, Saturn, stunning flybys, and was speeding out of the solar system at 40,000 miles per hour. Carl Sagan, the dreamer behind Cosmos, had an idea: turn Voyager's camera around, just once, for a family portrait of our cosmic neighborhood. NASA wasn't thrilled. Cameras were for science, not selfies. But Sagan pushed, and on February 14th, they did it. From 6 billion kilometers away, 40 times the distance to the sun, Voyager snapped 60 frames. The result? Earth as a dot, less than a pixel wide, caught in a stray beam of sunlight scattering through the lens, like a mote of dust floating in a dark room. Sagan saw it and wrote one of the most haunting lines ever. "Look again at that. That's here. That's home. That's us. Every king, every war, every laugh. It's all crammed into that 0.12 pixel speck, 4 billion miles from Voyager's lens. But the photo's not just beautiful, it's brutal. Around that dot, nothing. No planets nearby, no stars close enough to notice. Just endless black, pierced by faint streaks of light from a sun that looks like any other star from that far out. Voyager wasn't built to see Earth like this. It was a fluke, a last gasp before its cameras shut off for good. But that image stuck. It's not just a snapshot. It's a mirror, showing us how tiny we are in a universe that doesn't seem to care. So what does it mean? On one level, it's simple. Space is big, we're small. The numbers back it up. 4 billion miles is nothing next to the 100 billion light years of the observable universe. Earth's a grain of sand on a beach that stretches forever. But stare at that pale blue dot long enough, and the quiet gets loud. Why does it feel so empty? Voyager didn't just catch our size, it caught our solitude. No neighbors popped up in that frame. No alien cities glowing back. Just us, dangling in the dark. Think about it. We've sent radio waves out for a century. TV, music, hello signals, traveling at light speed, reaching 100 light years by now. That's 2,000 stars, thousands of planets. Yet no one's answered. The pale blue dot isn't just isolated in space. It might be isolated in time, too. Are we late to the party? Did life bloom and fade billions of years ago, leaving us as the last one standing? Or are we early, alone because the universe hasn't woken up yet? Sagan thought it was humbling, a call to cherish our speck. But what if it's more? A hint we're the only voice in a silent choir. And here's the eerie twist. Voyager's still out there, 15 billion miles away now, drifting into interstellar space. It carries a golden record. Our sounds, our greetings, headed nowhere fast. In 40,000 years, it'll pass a star 1.6 light years away, but by then, its power's long gone. That pale blue dot photo, it's a postcard from a ghost ship, sailing a sea with no shore in sight. The pale blue dot hangs there, a pixel of light, a whisper of home, swallowed by the vastness. It's us, sure, but it's also a question. Are we all there is? Science says space should teem with life. Trillions of planets, endless chances. Yet this photo feels like proof of nothing. Maybe we're rare, a fluke on a fragile rock. Or maybe the silence is louder than we think, a universe holding its breath. As you drift off, see that speck in your mind, small, blue, alone. Sleep soft, or let the quiet keep you company. The missing baryon problem. Picture the universe as a giant recipe. Stars, galaxies, gas, all mixed from a cosmic soup born in the Big Bang. Scientists thought they had the ingredients figured out, but then they counted, and half the stuff was missing. Not dark matter, not energy, plain old matter. The stuff that makes you, me, and the Earth, gone without a trace. It's called the missing baryon problem, and it's like losing half the puzzle pieces to existence. Lie back. Let's hunt for the universe's lost building blocks in the dark. Let's rewind to the Big Bang, 8 billion years ago. The universe explodes into being, hot, dense, a soup of particles cooling into what we see today. Fast forward a bit, and you get baryons, protons and neutrons, the Lego bricks of normal matter. Think stars, planets, gas clouds. Everything that isn't dark matter or energy. Cosmologists worked out how much should be out there by studying the Big Bang's echo, the cosmic microwave background. It's a snapshot of the oldest light, etched with clues about the universe's makeup. They crunched the numbers. Baryons should make up 4 to 5% of everything, trillions of tons across space. But here's the hitch. By the 1990s, astronomers started counting what they could see, stars, galaxies, the hot gas in clusters. They used telescopes, X-rays, everything, and came up short, way short. They found the easy stuff, stars and cold gas in galaxies, about 10% of the baryon total. Hot gas in galaxy clusters added another 10 to 20%, but the rest? Half the baryons, billions of suns worth, were AWOL. It wasn't in black holes. Those are too rare. It wasn't locked in planets. Too small. The universe had a gaping hole in its inventory, and no one knew where to look. This wasn't a rounding error. Theory said 4 to 5% of the universe's mass energy budget was baryons, about 10 to the power of 80 particles. We were missing half, trillions of tons of matter that should be shining, glowing, or at least sitting there. For decades, it was a cosmic cold case, the missing baryon problem. So where'd they go? The first guess was obvious. Maybe we just can't see them. Stars and gas in galaxies are bright, easy to spot. But what about the dark corners, between galaxies, in the voids? Astronomers theorized a cosmic web, filaments of gas threading the universe, too faint to catch with normal scopes. Problem was, this stuff would be warm, not hot enough to blaze in X-rays like cluster gas, not cold enough to clump into stars. It's the Goldilocks zone of matter. Invisible unless you know how to look. Then came the breakthrough. In the 2010s, teams used a trick. Quasars, super bright cores of distant galaxies. Their light cuts through space like a flashlight, and when it passes through gas, it leaves fingerprints, absorption lines in the spectrum. By 2017, two groups found it. Wispy, million-degree tendrils of oxygen and hydrogen stretching between galaxies. They called it the warm-hot intergalactic medium, WIM, and it held the missing half, spread thin across billions of light years. Case closed, right? Not so fast. Here's the twist. The WIM's tough to pin down. It's diffuse, 10 particles per cubic meter, a trillion times thinner than Earth's air. Some say we've only glimpsed it. Maybe there's more hiding, or maybe our counts are off. What if it's not all WIM? Could some baryons be locked in rogue planets, drifting unseen? Or, wild thought, what if they're not missing, just changed? Converted by some unknown physics into something we can't detect? The universe loves a good hide-and-seek game, and this one still got shadows to explore. The missing baryon problem's half solved. A ghostly web of warm gas threading the void, holding the stuff that makes us. It's out there, faint and sprawling, tying galaxies together like cosmic veins. But doubts linger. We found pieces, not the whole pile. Trillions of tons still whisper in the dark. Maybe it's all WIM, waiting for better eyes. Or maybe the universe is slyer than we think, hiding its bricks in plain sight. As you drift off, imagine that missing half, scattered, silent, everywhere. Sleep deep, or let the unseen hum keep you wondering. Fast radio bursts, FRBs. Imagine you're stargazing, and suddenly the sky screams. A burst of radio waves, brighter than a million suns, slams into Earth for a split second, then vanishes. No warning, no trace. Since 2007, we've been catching these fast radio bursts, FRBs, flashing from the deep cosmos, and we still don't know what's yelling. Are they stars exploding? Aliens signaling? Or something we can't even dream up? Lie back. Let's tune into these ghostly shouts from the void. It all began in 2007. When astronomer Duncan Lorimer was digging through old data from the Parkes telescope in Australia, a big dish built to listen to the universe's whispers. He found something bizarre, a radio signal, just 5 milliseconds long, so intense it outshone everything else in the sky. It wasn't a glitch, too sharp, too clean. His team traced it back to a spot 3 billion light years away, meaning it happened when Earth was still a toddler planet. They called it the Lorimer burst, the first fast radio burst, or FRB, ever caught. After that, the floodgates opened. By the 2010s, telescopes like Arecibo and the Canadian Chime were snagging dozens more brief, millisecond blasts packing the energy of 500 million suns. Most were one-offs. Blink and they're gone. But in 2012, we found a repeater, FRB 121102, spitting burst from the same dwarf galaxy 3 billion light-years out. Each FRB's a radio spike, a trillion times brighter than a pulsar's pulse, hitting us from random patches of sky. Some days, Chime catches 3 in an hour. Others, it's dead quiet. Here's the wild part. They're everywhere. Estimates say 1,000 FRBs hit Earth daily, right now. As you listen, dozens are flashing overhead, but they're so quick, so faint, we only catch a handful with the right gear. Whatever's making them, it's pumping out insane power, enough to cross billions of light years and still rattle our antennas. So what's behind these cosmic tantrums? The safe bet's nature gone wild. Top suspect: magnetars, dead stars with magnetic fields a trillion times Earth's, so strong they can rip atoms apart. A flare from one could spit a radio burst. FRB 200428, caught in 2020 from a magnetar in our galaxy, backs this up. But most FRBs come from far beyond, billions of light years, and magnetars don't fully explain the repeaters or the sheer numbers. What else? Colliding neutron stars? Possible. Mergers blast energy, but they're rare, and FRBs are common. Then there's the fun stuff. Aliens. Imagine a civilization beaming signals, maybe light sails, maybe messages, across the cosmos. FRB 121,102's repeats got SETI buzzing. Its host galaxy, small and star-forming, could cradle life. But here's the snag. No pattern, no code, just random shouts. If it's aliens, they're not chatty. Some even wonder, could FRBs be cosmic glitches? Leftover pops from the Big Bang? Or space-time itself hiccuping? No evidence, but no rules against it either. And get this, we're still counting. Chimes clocked over 500 FRBs since 2018, and repeaters keep popping up. FRB 180916 fires every 16 days like clockwork. But the one-offs? They're a mystery parade. Each from a different corner, each a lone cry. Are they all the same beast, or a dozen weirdos shouting at once? The universe is loud, but it's not telling us why. Fast radio bursts are space's unsolved symphony, brief, brilliant, and baffling. Magnetars might explain some, collisions others, but the full chorus stays out of tune. Maybe they're just stars throwing fits, or maybe they're echoes of something bigger, civilizations, glitches, secrets we can't crack. As you drift off, feel those bursts raining down, 1,000 a day, silent to your ears, screaming to the sky. Sleep calm, or let the static whisper you awake. The dark flow, picture the universe as a giant ocean. Galaxies drifting with the tide of expansion, spreading out since the Big Bang. Now imagine a hidden current, pulling thousands of them off course, toward a spot we can't see. It's called the dark flow, a strange, unseen force dragging chunks of the cosmos like a river in the void. Is it gravity's shadow, or something breaking the rules? Lie down. Let's ride this cosmic undertow into the dark. It started in 2008, when astronomer Alexander Kashlinsky was studying the cosmic microwave background, CMB for short, the Big Bang's leftover glow, a snapshot of the universe at 380,000 years old. He wasn't looking for motion, just tiny heat ripples in that ancient light. But he had a trick, the Sunyaev-Zeldovich effect. When CMB photons hit hot gas in galaxy clusters, they scatter, leaving a fingerprint. By tracking 700 clusters, some 6 billion light years away, he could measure their speed through space. Here's what he found. These clusters weren't just drifting with the universe's expansion, like everything should. They were moving, fast, up to 2 million miles per hour, all in the same direction, toward a patch between Centaurus and Vela constellations. Kashlinsky's team checked more, 1,400 clusters total, stretching halfway across the observable universe, and the pattern held. Something was pulling them, a flow cutting through the cosmic tide. They dubbed it the dark flow, a name that stuck because no one could see what was driving it. This wasn't small. We're talking thousands of galaxy clusters, trillions of stars, spanning billions of light years, all nudged the same way. Our own Milky Way's caught in it too, a passenger on this strange ride. It didn't match the smooth expansion Hubble taught us. The universe was supposed to spread evenly, not lean into a secret stream. So what's steering this flow? The obvious culprit's gravity, some massive pile of stuff beyond our sight. Maybe a super-duper cluster, dwarfing even the Great Attractor, which pulls us at a measly 3 million miles per hour. But here's the snag. The dark flow stretches too far, half the universe, and keeps going past the Great Attractor's reach. To tug that hard, You'd need a monster 10 times bigger than anything we've mapped, packed with dark matter and galaxies. Problem is, our best scopes, like Planck, see no such beast out there. Then it gets weirder. Some say it's not in our universe at all. What if the dark flow's a pull from beyond, a neighboring cosmos, a bubble left over from inflation, yanking us through space-time? Kashlinsky floated this. Maybe the Big Bang wasn't one bang, but many, and we're feeling the echo of another reality. Wild, right? No proof, pure theory, but it fits the data's stubborn tilt. Others argue it's dark energy misbehaving, pooling unevenly, dragging matter like a cosmic undertow. But not everyone's sold. Planck's 2013 CMB data couldn't confirm it. Some say the dark flow's just noise, a glitch in the math. Yet Kashlinsky's clusters keep showing that drift, defying the critics. Is it real? A shadow of something massive? Or a crack in our picture of the universe? A flow leading nowhere, or everywhere, that we can't follow? The dark flow's a riddle wrapped in starlight, clusters sliding toward the unseen, a pull we feel but can't grab. Maybe it's a giant lurking past our horizon, maybe a whisper from another world, or maybe just a trick of the numbers. We're riding it either way, 2 million miles per hour into the abyss. As you drift off, imagine that current, silent, steady, sweeping us along. Sleep still, or let the dark tide carry your dreams. The black hole information paradox. Picture a black hole, a cosmic vacuum cleaner, swallowing everything, even light. You drop in a book, a star, your secrets. They're gone, shredded into nothing, or so we thought. But here's the twist. Physics says information can't die, yet black holes seem to eat it for breakfast and burp out nonsense. It's called the black hole information paradox, and it's been tearing at the fabric of reality since the 1970s. Lie back. Let's fall into this riddle where even the universe might lose its memory. It starts with quantum mechanics, the rulebook for the tiny stuff, atoms, particles, you name it. One big rule. Information, every detail about a particle's state, never vanishes. Burn a book, and its info scatters in the ash and heat. You could, in theory, piece it back together. Now meet black holes, born when massive stars collapse, packing so much gravity that nothing escapes, not even light. By the 1960s, we thought they were simple. Mass, spin, charge, done. Drop something in, it's crushed into a singularity, a point of no return. Then Stephen Hawking flipped the script. In 1974, he showed black holes aren't dead ends, they leak. Quantum quirks near the event horizon, the no escape line, spawn particle pairs. One falls in, the other zips out as Hawking radiation. Over eons, trillions of years for a big one, the black hole evaporates, shrinking to nothing. Cool, right? Except for one problem. That radiation's random. It carries no trace of what fell in. Your book, that star, gone. Information erased. But quantum mechanics screams, that's illegal. This clash kicked off the paradox. If info's lost, quantum rules break. If it's not, where does it go? Hawking's math said a stellar mass black hole, 10 suns, takes 10 to the power of 67 years to vanish, spitting bland radiation the whole time. By 1976, physicists were in a panic. Two pillars of science, quantum mechanics and gravity, were at war. So, where's the info hiding? One fix. It's not lost. Hawking radiation secretly encodes it. Picture a hologram. The black hole's surface, the event horizon, stamps every detail of what falls in, then leaks it out scrambled in the radiation. It's called the holographic principle, and it's wild. 3D stuff flattened to a 2D skin. By the 1990s, string theorists ran with it, saying info's safe, just mashed beyond recognition. Problem? We can't decode it yet. But what if it's deeper? Some say the info falls through, into a wormhole, a tunnel to another universe. Drop your book, and it pops out somewhere else, intact. Cool, but untestable. Wormholes are sci-fi for now. Then there's Hawking's late twist. In 2004, he flipped, betting info escapes, not lost. He lost a bet to John Preskill over it, paid with a baseball encyclopedia. Still, no one's sure how. Could it hide in the singularity, that infinite dot, and vanish when the black hole does? Here's the eerie catch. Black holes might be shredding reality itself. If info dies, our laws unravel. Cause and effect, time, everything. Or maybe it's locked in a cosmic vault we can't crack. New ideas, like quantum firewalls or fuzzballs, keep popping up, but the paradox holds. Every black hole out there, millions in our galaxy, might be a glitch in the universe's hard drive. The black hole information paradox lingers, a shadow where physics stumbles. Maybe the info's smuggled out, a whisper in the radiation. Maybe it's gone, and we're wrong about everything. Or maybe it's waiting, trapped in a void we can't reach, a memory the universe forgot to keep. As you drift off, imagine those black holes, silent, swallowing, humming with secrets. Sleep tight, or let the lost bits haunt your dreams. The Fermi Paradox's silent universe. Look up at the night sky. Billions of stars, trillions of planets, a universe buzzing with possibility. In 1950, Enrico Fermi, a physics legend, stared at that same sky and asked, "Where is everybody?" With all those worlds, we should have heard something. Radio chatter, a cosmic hello. Instead, silence. It's the Fermi Paradox, a quiet that deafens the stars. Are we alone? Late? We're just not listening right. Lie back. Let's wander this hushed cosmos together. It started over lunch at Los Alamos, 1950. Fermi, Nobel Prize winner, nuclear genius, was musing with colleagues about aliens. The numbers were staggering. The Milky Way's got 100 billion stars, many with planets. By 1961, Frank Drake crunched it with his famous equation. Factor in star formation, planets, life odds. And even conservative guesses spit out millions of intelligent civilizations. Some should have mastered radio by now, beaming signals our way. Earth's been shouting since the 1930s. TV, music, SETI pings, reaching 100 light years out, a bubble touching 2,000 stars. Fermi's point was blunt. If they're out there, why no trace? No ships, no probes, no whispers on our scopes. We've been hunting since SETI's dishes, like Arecibo, swept the sky for decades. The WOW signal in 77 was a tease, 72 seconds of hope, but nothing since. By the 2000s, Kepler found exoplanets galore, billions in our galaxy alone, thousands in habitable zones. The math says we should have bumped into someone, yet the universe stays mute. A silent orchestra with no players. This isn't just our galaxy. The observable universe holds 2 trillion galaxies, 10 to the power of 24 stars. Give or take. Even if life's rare, the odds stack up. Fermi's paradox isn't a question, it's a void, a silence so deep it's been nagging us for 75 years. So why the quiet? One answer's brutal: we're alone. Earth's a fluke, life's spark, brains, tech, all a cosmic lottery we won solo. The great filter theory says maybe it's hard. Amino acids to cells, or cells to minds, or minds to machines. Some steps a wall, and we're the only ones past it. But with trillions of chances? Feels thin. What if the filter's ahead? Civilizations self-destruct, nukes, or AI gone rogue before they can shout? Or maybe they're out there, hiding. The zoo hypothesis paints us as ants. Aliens watch, but don't buzz us, keeping the galaxy a nature preserve. Dark forest flips it darker. Everyone's quiet because noise gets you hunted. Broadcast, and something eats you. Creepy, right? Then there's time. Maybe we're early. Life's just sprouting elsewhere. Or late, and they're all gone. Dust from empires we missed by a billion years. Tech twisted too. Maybe signals fade, radio's old news, and they're on quantum chats we can't catch. Or they're here, but tiny, probes the size of dust, buzzing past unnoticed. The silence isn't empty, it's loud with maybes. Are we shouting into a graveyard? A crowd holding its breath? Or a universe that never woke up? The Fermi Paradox's silent universe echoes on. A trillion stars, and not a peep. Maybe we're the first, the last, the only. Or maybe they're there, whispering in ways we can't hear. It's a hush that cradles every planet, every hope, every what if. As you drift off, feel that quiet, vast, heavy, alive with shadows. Sleep soft. or let the silence sing its lonely tune. The cosmic web's ghostly glow. Imagine you're standing outside at night, staring up at the sky. You see stars, bright little pinpricks, and a whole lot of nothing between them. But what if that nothing wasn't so empty? What if it glowed, faintly, eerily, like a spider web catching the last gasp of twilight? That's the cosmic web, the universe's hidden skeleton, threads of gas and dark matter stitching galaxies together. In 2019, astronomers caught its shimmer for the first time, a ghostly light from the Big Bang's leftovers. It's beautiful, sure, but here's the creepy part. It's glowing more than it should. Why? Is it just gas, or something whispering in the dark? Let's dive into this cosmic mystery, and try not to get tangled. This all starts in Chile, 2019, with a telescope called MUSE, Multi-Unit Spectroscopic Explorer, if you're feeling fancy. Picture it, a hulking machine perched on a mountain, staring into the abyss. A team led by astronomer Erica Hamden aimed it at Fornax, a quiet little constellation near the southern sky, and hit record. They weren't chasing stars or planets. They wanted the gaps, the filaments of the cosmic web. These are long, wispy tendrils of hydrogen gas, stretching millions of light years, linking galaxies like some vast, interstellar highway system. Theory said they'd glow, just a whisper, lit up by quasars, those blazing cores of ancient galaxies. So they waited for 140 hours. That's nearly 6 days of staring at nothing, hoping to see something. And then, bam, there it was. What they caught was a bluish haze, hydrogen atoms twinkling at 121, 6 nanometers, a wavelength called the Lyman alpha line. Think of it like a trillion-mile-long candle, flickering so faintly you'd miss it without a monster like MUSE. This wasn't a shock. We'd mapped the web with math for years. Picture the universe as a giant sponge. Galaxies are the clumps, filaments the strands, all sculpted by gravity and dark matter 13 billion years ago, right after the Big Bang cooled off. MUSE just made it real, a glowing snapshot of that ancient scaffolding. Pretty cool, right? But here's where it gets unsettling. That glow? It's too bright, way too bright. Let's break this down. The Big Bang left us a cosmic recipe for percent normal matter, stuff like hydrogen, called baryons, 27% dark matter, and 68% dark energy. Those filaments should be razor thin, a measly sliver of that 4%. Quasars, super bright galaxy hearts, should zap them with enough juice to glow, but just barely. Except MUSE saw more, a lot more. It's like ordering a single candle and getting a chandelier. So what's going on? Is there extra gas we didn't count? More hydrogen sloshing around between galaxies than we thought? Maybe, but that messes with the Big Bang's math. Where'd it come from? Did we miss a delivery truck 13 billion years back? Or, here's a creepier thought, what if it's not just gas? Some physicists whisper about dark matter. You know, that invisible stuff holding the universe together. What if it's decaying out there, spitting out photons, light particles, that juice up the glow? There's no hard proof, but the idea is tantalizing. Imagine it, dark matter, silent for eons, suddenly flickering to life in these threads. Or, okay, stay with me. What if it's a relic of inflation? That wild, split-second stretch right after the Big Bang, when space ballooned faster than light. Maybe it left energy pockets, glowing like cosmic scars in the web. Sounds sci-fi, sure, but the math doesn't rule it out. Now, let's zoom in on the data, because it gets weirder. That glow isn't uniform. It's patchy, bright knots where filaments tangle, dim stretches where they thin out. It's like a fingerprint, but half erased. MUSE caught a tiny piece, just a few million light years of this sprawling network. Newer scopes, like the James Webb, might map more, but for now, it's a tease. And here's the part that sticks with you. If it's not just gas lighting up, what's out there? Something drifting through those threads, unseen, pumping energy into the void. The cosmic web's the universe's backbone, holding galaxies, clusters, us, but it feels alive, elusive, like it's humming a tune we can't quite hear. Here's a fun fact to chew on. That glow's been traveling for billions of years. Some of it left when Earth was just a molten rock. Every night, it's up there, raining down, invisible without tools like MUSE. Think about that. A trillion miles of ghostly light, threading the sky, tying us to the start of everything. It's a cosmic tapestry, stunning, sure, but there's an edge to it. What's powering it? Is it just physics or something else? Something that doesn't want to be seen? Okay, let's play with this for a sec. Imagine you're floating out there, past the Milky Way, past the local group, into one of those filaments. It's cold, too. 7 Kelvin, just above absolute zero. Silent, but then you see it. A faint shimmer, stretching forever. You reach out, and it's gone. Just gas, or so they say. But what if it's not? What if something's moving through it, lighting it up as it goes? Scientists will tell you it's hydrogen, quasars, maybe a dash of dark matter. Fine, but that extra glow, it nags at you. It's like the universe left a light on in an empty room. So tonight, as you drift off, picture that web, faint threads glowing across the void, a network older than time. It's beautiful, no doubt, but unsettling too. What's fueling it? What's hiding in its shadows? Is it just the Big Bang's echo, or a signal we're too small to decode? Sleep easy, if you can, or let those whispers hum in your dreams. The redshift controversy. Picture this. You're looking up at the night sky, and every star, every galaxy, is running away from you. Not because they hate you. Well, maybe, but because the universe is stretching, expanding like a cosmic balloon. That's what their light tells us, shifting red as they flee. It's a story we've loved since Edwin Hubble cracked it in 1929. But in the 1970s, a guy named Halton Arp threw a wrench in it. He said, "Hold up, some of this redshift stuff? It's fishy." He found galaxies with redshifts that didn't match, tied together by glowing bridges of gas. Was he a genius? A nutcase? Or, here's the creepy bit. Is the universe playing a trick on us? Let's zoom into this cosmic spat and see if space is lying. First, redshift 101. When a galaxy moves away, its light stretches, like a siren dropping pitch as it speeds past. Hubble nailed it. The farther the galaxy, the redder the shift, proof the universe is growing. It's elegant, simple, and explains why everything's drifting apart at insane speeds. Some galaxies clocking millions of miles per hour. By the 60s, it was gospel, backed by the cosmic microwave background. That Big Bang hum we'll get to later. Then Arp, this telescope-wielding maverick, steps in. In the 1970s, he starts snapping pics of the sky, hundreds of them, and spots something weird. Galaxies and quasars, physically linked, but with redshifts that don't line up at all. Take NGC 4319 and Markarian 205, a galaxy and a quasar duo. NGC 4319's redshift says it's moving at 1,800 kilometers per second, pretty standard for its distance, about 100 million light years. Markarian 205, a screaming 21,000 kilometers per second, way farther, billions of light years, if redshift's your ruler. Except Arp's photos show a gas bridge. Think a glowing umbilical cord, tying them together. Neighbors, not strangers. He cataloged dozens of these oddballs. Galaxies cozying up to quasars, redshifts clashing like they're from different universes. So what's the deal? Are they close, or are we blind? Arp had a wild idea. Some redshifts aren't from motion. Maybe gravity warps them, like a black hole bending light, or some new physics we haven't dreamed up. His big pitch? The universe isn't expanding, or not the way we think. Redshifts might be intrinsic, baked into objects, not just distance markers. He'd point at his photos and say, "Look at these bridges. These things are connected." Mainstream astronomers? They laughed. Quasars are cosmic powerhouses, black holes eating stars, billions of light years off. Those bridges? Just optical illusions, chance alignments in a crowded sky. Case closed, right? Well, not so fast. Let's zoom in on those pics, because they're eerie. Picture a galaxy, all spiral and calm, with a quasar, bright, violent, hanging nearby. Between them, a thread of gas, glowing like it's alive. Arp's got dozens, hundreds, of these. If he's wrong, why do they look so real? The standard line is redshift tracks speed, speed tracks distance, distance tracks expansion, done. The CMB, that 13.7 billion year old echo, seals it. The universe grew from a hot, stuck to this sprawling mess. ARP's quirks? Flukes? They say, projections on a 3D sky fooling our 2D eyes. By the 80s, he was sidelined. Telescopes turned elsewhere, his grants dried up. But those bridges, they nag at you. Here's where it gets unsettling. What if ARP was onto something? What if redshifts not the whole story? Could dark energy, that invisible push stretching space, mess with light in ways we don't get? Or, stay with me, what if some galaxies are faking it? Hiding closer than their redshift screams, tied to neighbors by threads we can't explain? Imagine looking up and realizing half the sky's a lie. Distance is scrambled, the universe not expanding, but something else. ARP didn't have proof, just pics and a hunch, but he fought till his last breath in 2013, a lone rebel against the cosmic choir. Today, we stick with Hubble. Redshifts our ruler, expansions our truth. The CMB, mapped by Planck in 2013, locks it tight. 67 kilometers per second per megaparsec, give or take. ARP's a footnote, his intrinsic redshift, a ghost story for astronomy nerds. But those gas bridges? They're like footprints in the dark, too neat to ignore. Fun fact, quasars shine so bright they'd outglow our sun 1 trillion times. Yet ARP thought some were next door. Crazy? Maybe. Creepy? Definitely. Let's play a game. Imagine you're an astronomer, peering through ARP's lens. You spot NGC 4319, quiet, normal, then Markarian 205, blazing, redshift screaming far away. But there's that bridge, glowing, mocking you. Are they close? Is redshift broken? Or is the universe stitching itself together in ways we can't fathom? Scientists say it's a trick, perspective fooling us. Fine, but what if it's not? What if space is a house of mirrors, reflecting lies we've built our maps on? So tonight, as you drift off, picture those bridges, glowing threads across the void, tying galaxies to quasars in a dance that doesn't fit. It's a cosmic puzzle, beautiful, sure, but there's a shadow in it. Is space stretching or staging a con? Every telescope we build might bury ARP deeper, or crack the facade wide open. Sleep tight, if you dare, or wonder what's really moving out there. The moon's far side mystery. Picture this. It's night, and the moon's up there, full, bright, staring down like an old friend. You've seen it 1,000,000 times, those dark patches we call Maria, like a cosmic Rorschach test. But here's the thing, that's only half the story. The moon's got another side, a far side we never see from Earth. In 1959, a Soviet probe snapped it first, and it's weird. No smooth Maria, just a cratered wasteland, scarred and silent. Why is it so different? And here's the creepy part. Why does it feel like the moon's hiding something back there? Let's flip it over and take a peek into the shadows. First, why don't we see it? The moon's tidally locked. Its spin matches its orbit around Earth, 27. 3 days each way. So one side's always facing us, the other's turned away, like a shy kid at a party. That lock's courtesy of gravity. Earth's tug slowed it down over billions of years until it synced up perfectly. Cool, right? But in October 1959, the Soviet Luna 3 probe swung around and clicked the shutter. What it saw was a shock. The far side's a mess. 95% craters, rugged hills, almost no dark lava plains. Compare that to our side. 30% Maria, smooth and inviting. It's like the moon's got a split personality. One face we know, one we don't. Fast forward to the 60s, Apollo crews got a closer look. Buzz Aldrin, orbiting in Apollo 11, called it magnificent desolation. A lunar badlands, hawked and ancient. No Maria means no lava flows. Or way less, anyway. Why? Scientists scratch their heads. Theory 1. A cosmic smash. Picture this. 4 billion years ago, something huge, a rogue planet, maybe, slams the far side, cracking it open. The impact scars it with craters, while lava oozes out the near side, pooling into Maria under Earth's gravitational nudge. Makes sense. Big hits leave big marks. But here's the hitch. Why didn't lava flow back there too? Shouldn't it even out? Theory 2. Earth's pull did the heavy lifting. Our gravity might have tugged magma to the near side during the moon's molten youth, leaving the far side high and dry, literally. The crust's thicker there, 50 kilometers versus 30 on our side, per China's Chang'e-4 rover in 2019. That rover landed in the South Pole Aitken Basin, a monster crater 2,500 kilometers wide, one of the solar system's biggest scars. It dug up mantle chunks, rock from deep inside, hinting at a violent past. So maybe Earth sucked the life to our side, starving the far one. Neat, huh? But it's too tidy, something's off. Here's where it gets eerie. That far side, it's not just different, it's silent. No Maria, no water traces, just a battered shell staring into the void. In 2021, Chang'e-4 clocked a crater 100 kilometers wide, fresh enough to suggest recent chaos, maybe a million years old. Recent on a cosmic scale, anyway. So what if it's not just geology? What if the far side's a shield, scarred to catch cosmic bullets for us? Imagine asteroids raining down, the moon taking hit after hit to spare Earth. Or, stay with me, what if it's a graveyard? A dumping ground for ancient collisions, secrets buried in craters we'll never fully decode? Let's zoom in on that thickness. 50 kilometers of crust, that's 20 more than our side. Enough to hide a lot. Chang'e-4's still scraping away, but it's slow going. The near side's crust is thin, lava-friendly. The far side's a fortress. Fun fact, the moon's lopsided. Its center of mass is off by 2 kilometers toward Earth, thanks to that tug. So maybe it's physics, gravity sculpting a two-faced rock. But those craters, they feel deliberate, like something or someone wanted that side roughed up. Okay, let's play a game. Imagine you're on Luna 3, swinging around in 59. You see the near side, familiar, smooth. Then the far side rolls into view. It's a lunar apocalypse. Craters on craters, no friendly Maria waving back. Is it just nature? A big smash and some tidal tricks? Scientists say yes. Impact plus gravity. Case closed. Fine. But what if it's not? What if the moon's keeping watch? Its far side a battered sentinel, facing the dark so we don't have to. Apollo 17's Gene Cernan said it felt like another world. Maybe it is. Here's a creepy thought. The far side's been staring into space for 4 billion years, longer than life's been on Earth. What's it seen out there? Stars being born, planets dying, maybe things we can't imagine. And it's mute. No radio signals bounce off it naturally, no light show for us. Chang'e-4's the first to land there. Humanity's tiny toehold. But it's a speck on a vast, scarred face. 2,500 kilometers of basin alone. That's silence. It's deafening. So tonight, as you drift off, picture that far side. Craters glowing in shadow. A hidden face Earth never meets. It's our moon, sure, but there's a strangeness to it. Why so different? What's it guarding? Is it just a rock caught in our pull, or a witness to something bigger? Every night, it's up there, half known, half mystery. Sleep tight, if you can, or let those scars stand guard in your dreams. The Pioneer Anomaly. Imagine you're tossing a paper airplane off your roof. Simple, right? It glides, catches the breeze, and eventually drifts down. Now picture launching 2 tiny spaceships into the void, Pioneer 10 and 11. A couple of metal boxes no bigger than a minivan, sent off in the 70s to explore the solar system. They zipped past Jupiter, snapped some stunning shots of Saturn, then kept going, out into the deep black, beyond Pluto, where no one's been. They were supposed to coast forever, carried by momentum, free from the sun's grip. But in the 1980s, something grabbed them, slowly, faintly, tugging them back. It's the Pioneer Anomaly, a cosmic glitch that messed with our maps. Was it just heat? Or, here's the creepy part. Is something out there bending space itself? Let's follow these little wanderers and feel the pull. Pioneer 10 launched in 1972, Pioneer 11 in 73, twin probes with a simple gig. Sling around the outer planets, beam back pics, then sail off into interstellar space. They're scrappy, powered by nuclear batteries, pinging Earth with radio waves like cosmic postcards. By the 80s, they'd cleared the known solar system, past Pluto, into the Kuiper Belt, heading for the stars at 27,000 miles per hour. Scientists tracked them with Doppler shifts, those subtle stretches in radio waves as they moved away, like a car horn fading into the distance. Everything was textbook, until it wasn't. Around 1980, the numbers went wonky. The probes were slowing down by 8 billionths of a meter per second squared. That's a snail's pace, sure, but over years, it added up, 400,000 kilometers off course, back toward the sun. Okay, let's put that in perspective. Imagine you're driving cross-country, and your GPS says you're 250 miles behind where you should be. Except you're in space, and there's no traffic to blame. Scientists scratch their heads. Was it gravity? The sun's pull drops fast out there, by 20 astronomical units, 20 times Earth's distance to the sun. It's a whisper. Planets like Neptune? Too far to yank that hard. Maybe gas leaks, little puffs from the probe's thrusters. They checked. Nothing. Dust drag. Cosmic grit slowing them down. Nope. Space is too empty. By 2002, it was a full-blown mystery. Our equations failed, and these pioneers were drifting off script. So what's tugging them? The safe bet came in 2012. Heat. Those nuclear batteries, radioisotope thermoelectric generators, fancy name, glow with warmth, about 100 watts worth. If that heat radiates unevenly, say more out one side, it acts like a tiny rocket, nudging the probes back. Picture a hairdryer on low, pushing a feather, just enough to mess with their path. A team crunched the numbers, modeled every bolt, every wire, and it fit. The anomaly shrank from what the heck to, oh, okay, case closed, right? Well, not quite. That heat was always there. Why'd it take 30 years to spot? And some data still wiggles, a few percent off, like a stubborn itch. Here's where it gets eerie. These probes are out there, way out there, 15 billion miles now, the farthest human-made things ever. Pioneer 10 went silent in 2003, 11 and 95, but they're still drifting, carrying golden plaques with our hello to the stars. That slowdown. It's like an invisible hand reached out, tapped the brakes, and let go. What if it's not just heat? What if dark matter's lurking? Those unseen particles we think fill space, grabbing them faintly. No proof, but it's a thought. Or, stay with me. Could space-time itself be funky out there? Some physicists toy with ideas like modified gravity, Newton and Einstein bending in the Boötes. Wild. Sure, possible. Maybe. Let's zoom in on that tug. 8 nanometers per second squared. It's tiny. Your hair grows faster. But over decades, it's real. By the 90s, they were 10 billion miles out, 80 Australian dollars, and still slowing. The heat fix is slick. Engineers love it. But it's almost too perfect. Imagine you're lost in a forest, and your compass starts spinning. You blame the batteries, swap them out, and it's fine. Except it keeps twitching. That's the Pioneer anomaly. Solved, but with a shadow. Fun fact, Pioneer 10's last signal took 11 hours to reach us. Lights slow when you're that far. Okay, let's play a game. You're on Pioneer 10, coasting past Saturn's rings. Gorgeous, icy, serene. You wave goodbye to the sun, now a dim dot, and settle in for the long haul. Years pass, decades, and then you feel it. A nudge, faint, steady, pulling you back. Is it your ship, leaking heat like a tired engine? Scientists nod. Yep, that's it. Fine, but what if it's not? What if the void's got fingers, something unseen, tweaking your path? The heat story's solid, tested, published, applauded. Yet that wiggle, that leftover bit, it's like a whisper in the dark. Here's the creepy kicker. They're still out there, silent, drifting, tugged by something. In 40,000 years, Pioneer 10 might graze a star in Taurus, maybe. But right now, it's alone, a ghost ship in a sea of nothing. That anomaly, it's a tiny crack in our cosmic GPS, a hint that space might not play by our rules. Picture it. 2 little probes, reaching for infinity, and something pulls them back, just a touch. So tonight, as you drift off, imagine those pioneers, floating in the black, their golden plaques glinting faintly. They're ours, sure, but there's a strangeness to them. What slowed them? Heat, probably, or something bending space itself. Every signal they sent was a plea. Here we are, answered by silence and a tug. Sleep easy, if you can, or feel the void reaching back in your dreams. Imagine you're handed a giant ruler and told to measure the universe. How fast it's growing, how quickly galaxies are racing apart. Sounds like a blast, right? That's what astronomers do with something called Hubble's constant, a magic number tying speed to distance as space stretches from the Big Bang. For decades, we thought we had it locked down, a cosmic speed limit we could bank on. But lately, that ruler's gone rogue. Two ways to measure it. One from the oldest light we can see, another from stars right in our backyard, clashed by a solid 10%. It's the Hubble tension, and it's snapping our cosmic blueprint in half. Is it just a glitch? Or, here's the eerie twist. Are we completely wrong about how the universe ticks? Let's stretch that ruler out and see what's cracking. This all kicks off with the Big Bang, 8 billion years ago. A hot mess explodes into existence, and space starts expanding like dough rising in an oven. Galaxies zip away, their light shifting red as they flee. Redshift, our universal speedometer. In 1929, Edwin Hubble, this sharp-eyed astronomer, figures it out. The farther a galaxy, the faster it moves. He plots it, speed versus distance, and boom, Hubble's constant is born. It's a rate. How many kilometers per second a galaxy picks up for every megaparsec? 26 million light years. It's a way. Simple, elegant, and it tells us the universe is ballooning. Fast forward to today, and we've got two killer ways to pin that number down. Problem is, they don't agree. First up, the cosmic microwave background, CMB for short. It's the Big Bang's afterglow, a snapshot from 380,000 years after the bang, when the universe cooled enough for light to break free. Think of it as a baby picture, etched with tiny hot and cold spots, quantum hiccups frozen in time. In 2013, the Planck satellite maps it with insane precision. Every ripple, every wobble. Crunch those numbers, factor in dark energy and matter, and you get 67 kilometers per second per megaparsec. 67 kps/mpc. That's the early universe's Void. Smooth, steady, a cosmic heartbeat from the dawn of time. Every million light years, space stretches 67 kilometers wider each second. Got it? Good. Now flip the script to method 2, the local stuff. We grab supernovae, stars that blow up, bright as a billion suns, and Cepheid stars, these pulsing lighthouses we can measure for distance. Teams like SH0ES, supernova H0 for the equation of state. Catchy, huh? Clock these beacons. In 2021, they tally it up, 73 kps/mpc. That's 6 units higher, 10% off. Doesn't sound huge, but scale it up, billions of light years, and galaxies are millions of miles per hour out of whack. It's like two runners timing a race. One says 67 seconds, the other 73, and the track's melting. That's the Hubble tension. Two gold standard measures, one universe, and they're at war. So what's the deal? Let's dig in. Option 1, the CMB skewed. That ancient light assumes dark energy. This invisible force pushing space apart stayed constant since day one. What if it didn't? Maybe it surged early, stretching the baby universe faster than Planck guesses, leaving echoes we misread. Possible. Dark energy's 68% of the cosmos, and we barely get it. Option 2, the local stuff's lying. Dust could dim those supernovae, tricking us into thinking they're farther. Or Cepheids, variable stars pulsing like heartbeats, might wobble oddly, throwing off our math. In 2023, the James Webb Space Telescope double-checks. Nope, 73 holds tight. Both could be off a hair, but 10%? That's no typo, it's a rift. Here's where it gets creepy. If this gap's real, our whole cosmic story's on thin ice. Hubble's constant sets the universe's age, 8 billion years. Tweak it, and stars might predate the Big Bang. Awkward. Dark energy could be a chameleon, shifting over eons. Or inflation, that wild stretch right after the bang, went haywire, warping our view. Some toss-out wild cards. New particles, early dark energy, even a pre-Big Bang bounce, like the universe recycled itself. Picture it, space stretching unevenly, a funhouse mirror twisting our ruler. Fun fact, Hubble dodged this fight. He died in 53, before his constant got famous. Smart move. Let's play a game. You're an astronomer with two clocks, CMB ticks 67, clean and ancient. Supernovae flash 73, bright and now. Which wins? Scientists shrug. Both are rock solid, yet they brawl. Average them. Nah, that's dodging the punch. What if neither's right? What if space is a trickster, expanding in ways we can't pin down? Every galaxy we chart, every redshift we clock, hangs on this number. Get it wrong, and the cosmic timeline buckles. Past, present, future, all shaky. Here's the unsettling bit. It's not just numbers, it's reality. That 10% gap means galaxies are speeding or dawdling off our maps. In 2024, new toys like Webb and Gaia are piling data, tightening the screws or blowing it wide open. Maybe it's dust, maybe dark energy's a shapeshifter, or, stay with me, could the universe be layered, hiding rules we haven't cracked? Imagine a trillion stars, all misplaced because our rulers bend. Every redshift's a guess, every distance a gamble. So tonight, as you drift off, picture that stretch, space pulling apart, tugging galaxies, unsure of its own pace. Ancient light hums 67, nearby stars shout 73, and the gap's a shadow on our sky. It's growing, sure, but how fast? Sleep on it, if you can, or wonder what's steering this cosmic chaos. The missing lithium problem. Imagine the universe as a cosmic kitchen, firing up the Big Bang stove 8 billion years ago. It's a frantic cook-off, protons and neutrons smashing together, whipping up the first elements. Hydrogen, light and simple, check. Helium, sturdy and stable, yup. Lithium, the lightest metal, a little sprinkle of cosmic seasoning, should be there too. Theory says old stars, born from that first batch, should be packed with lithium-7, a Big Bang leftover. But when we peek inside, it's barely a trace, 70% less than the recipe calls for. It's the missing lithium problem, a dish that didn't turn out. Did it burn up? Vanish into thin air? Or, here's the spooky twist. Did we misread the cookbook from the start? Let's stir this pot and taste the void. Rewind to the Big Bang's opening act, 3 minutes in, to be exact. The universe is a furnace, billions of degrees Kelvin, a soup of quarks and leptons cooling fast. Protons and neutrons start dancing, fusing into nuclei. Hydrogen, one proton, forms in droves. Helium, 4, 2 protons, 2 neutrons, locks in tight. Lithium, 7, 3 protons, 4 neutrons, gets its shot, about 1 in 10 billion particles per the models. It's a precise mix. The cosmic microwave background, that Big Bang echo mapped by Planck, nails hydrogen and helium ratios like a champ. Lithium's next in line, old stars, called population 3, born from that primordial brew, should shine with it. We crack their light open with spectra. Think a cosmic barcode, lines showing what's inside. Hydrogen, overflowing. Helium, stacks of it. Lithium, a ghost, 3 times less than we expect. So where'd it go? Option 1, stars ate it. Lithium's a delicate snowflake. At 2 million Kelvin, it fuses into heavier stuff, and poof, gone. Picture a campfire, toss in a marshmallow, and it's toast. But these stars, ancient dwarfs, some 10 billion years old, are cool, too dim to burn at all. In 2023, the James Webb Space Telescope scopes them out. Lithium's still AWOL. Option 2, the Big Bang botched it. Tweak the baryon count, normal matter's slice of the pie, and lithium drops. Less protons, less fusion, less metal. But that screws the CMB. Hydrogen and helium wouldn't match, and they do. Dead end. Here's the eerie part. What if it's hiding? Some say lithium sank into stellar cores, like sugars settling in coffee, out of sight in spectra. Or it drifted into interstellar gas, too faint to catch. In 2022, a study floats lithium rain, atoms falling deep into stars, locked away. Neat, huh? But 70%? That's trillions of tons playing hide and seek. Or, stay with me, what if it never was? Some wildcards pitch a second Big Bang, a lithium light remix, or a cosmic glitch where it fused away before stars formed. Spooky? You bet. Proven? Not a chance. Let's zoom in on those stars. Relics from 10, 12 billion years back. Their light's a time machine. Spectra screaming, where's the lithium? Fun fact, lithium's in your phone battery. Here, it's king. Out there, it's a pauper. In 2024, Webb's sniffing gas clouds. Maybe it's there, not stars. But the gap's massive, a hole in creation. Picture it, stars glowing, missing their spark, like a cake with no sugar. The Big Bang's recipe was tight. Hydrogen, helium, bang on. Lithium? A fumble. Imagine you're that cosmic chef. You follow the cookbook. Protons, neutrons, heat, time. Serve it up, and stars form. You taste it. Hydrogen, helium, perfect. Lithium? Barely a hint. Did it burn? Sink. Scientists nod. Stellar cores, maybe gas clouds. Fine, but what if the book's wrong? What if the universe skipped a page? Or something snatched it before we looked? Every old star's a clue. Every spectrum a taunt. 70% gone, no trace. Here's the chill. Lithium's small but mighty. Batteries, bombs, us. Yet the cosmos skimmed. That gap, it's a ghost in the stars, a whisper of a broken start. So tonight, as you drift, picture those ancient lights. Faint, lithium shy, humming a tune off key. Did it vanish? Or did we misread the bang? Sleep tight, if you dare, or wonder where it's lurking. Imagine you're strolling through your backyard, poking around the edges where the grass meets the wild. Maybe a fence, maybe a hedge. Now scale that up, way up, to the edge of our solar system. Out past Neptune, there's a ring of icy rocks called the Kuiper Belt, a cosmic junkyard full of Pluto's cousins, leftovers from the sun's messy birth. It stretches wide, a chilly neighborhood of frozen wanderers orbiting in the dark. But here's the weird part. It doesn't fade out like you'd expect. It just stops. At 50 astronomical units, 50 times Earth's distance to the sun, it drops off, sharp as a cliff. It's the Kuiper Cliff, and it's too neat to be random. What carved this edge? A hidden planet? A rogue star? Or, here's the creepy bit. Is something still out there, pruning the void? Let's trek to the rim and peer over. First, let's map this place. The Kuiper Belt kicks off around 30 Australian dollars. Neptune's orbit, and sprawls out to 50 Australian dollars. An AU's about 93 million miles. So we're talking 6 billion miles from the sun at its farthest. It's packed with icy bodies, comets, dwarf planets like Pluto and Eris, chunks of rock and frost from 6 billion years ago, when the solar system was a construction site. Think of it as the sun's attic. Stuff we didn't need, tossed to the fringes. Astronomers spotted it in the 90s, thanks to folks like Jane Liu and David Jewett, who nabbed the first Kuiper object beyond Pluto in 1992. They figured it'd taper off, fewer rocks as you go, a slow fade into the Oort cloud, that distant shell of comets way out at 100,000 Australian dollars. But no, at 50 Australian dollars, it's like someone hit pause. Objects just vanish, a clean cut in the cosmic grass. Why is that weird? Picture a beach. Sand thins out as you walk from the shore, not a brick wall at 50 feet. The Kuiper Belt should do that, scatter gently into nothing. Instead, it's a cliff. Telescopes like Hubble and ground-based beasts confirm it. Past 50 Australian dollars, the density plummets. Sure, we found a few stragglers, like Sedna at 85 Australian dollars, but they're rare, oddballs with wild orbits. The bulk stops cold. It's not empty beyond, just sparse, a gap before the Oort cloud kicks in. So what's the deal? Did nature draw a line, or did something else? Theory 1, a planet did it, not Neptune. It shepherds the inner edge at 30 Australian dollars. But something bigger, farther out. Enter Planet 9. The ghost world astronomers like Mike Brown and Konstantin Batygin have been hunting since 2016. They say a massive planet, 5 to 10 Earths worth, could have swept through, clearing rocks past 50 Australian dollars like a cosmic broom. Its gravity would tug orbits into weird shapes, explaining Sedna's loopy path. Problem is, we haven't found it. Telescopes scan, but it's a needle in a haystack, maybe too dim or too far. Still, those orbits hint at something heavy lurking. Cool, right? But it's a maybe. Planet 9's still a theory, not a photo. Theory 2, the sun's old neighbors. Back 6 billion years, The sun was born in a stellar nursery, a cluster of baby stars, all cozy and chaotic. A passing star could have swung by, its gravity shaving the Kuiper belt like a lawnmower. Picture it, a stellar flyby, trimming the edge at $50, then drifting off into the galaxy. Makes sense, stars wander, and clusters break up. But where's the culprit? After billions of years, it's long gone, no fingerprints left. Plus, the cut's so sharp. Would a random pass be that precise? Here's where it gets eerie. What if something's still out there? Not a planet we'd spot, but a rogue. Maybe a brown dwarf, a failed star too faint to see, parked just beyond. Or, stay with me, a black hole, a tiny one, primordial, from the Big Bang, massing a few Earths. Its gravity could carve that cliff, bending space without a glow. Wild. Sure, in 2019, some physicists floated it. Math works, but we'd need wild luck to catch it. Imagine that. Something invisible, pruning our backyard, watching us fumble. Let's zoom in on that edge. $50 for 6 billion miles out. The sun's a pinprick there, 1/2500 th its brightness from Earth. Pluto's at $39, Eris at 45. Then, bam, the cliff. In 2022, the Vera Rubin Observatory fired up, hunting for more. Early data's trickling in. If Planet 9's real, it might pop up. Fun fact, the Kuiper Belt's got over 100,000 objects bigger than 100 kilometers, yet past $50, it's a ghost town. Picture it, a frozen rim, then nothing, a silent drop-off into the dark. Okay, let's play a game. You're an explorer, sailing past Neptune. Icy rocks everywhere, a cosmic junkyard. You hit $50, and it's gone. Space opens up, eerily quiet. Is it a planet's wake? Scientists nod. Maybe, gravity's a sculptor. Fine, but what if it's not? What if something's lurking, trimming the belt, keeping it neat? A star's old pass, sure, but that cliff's too crisp. A black hole, too sci-fi, yet the math teases us. Every rock we chart, every orbit we trace, dances around this edge. Here's the creepy bit. That cliff's been there since the sun was born for 6 billion years, a boundary we're just now probing. Voyager 1 and 2 blew past it, $120 now, but they didn't look back. In 2025, Rubin's full sweep might nail it, Planet 9 or bust. But the silence beyond, it's heavy. Imagine standing at that rim, the sun a faint dot, rocks ending sharp. What cut it? Nature's quirk, or a shadow we can't see? Every AU we map, every telescope we aim, might reveal a sculptor, or a void staring back. So tonight, as you drift off, picture that cliff, icy rocks halting, a cosmic edge in the dark. It's our solar system, sure, but there's a strangeness to it. Did a planet sweep it? A star slice it? Or is something still out there, holding the line? Sleep tight, if you can, or scan the black for what's waiting. The axis of evil. Imagine you're tuning an old radio, twisting the dial through static until you catch a faint hum. The oldest sound in the universe. That's the cosmic microwave background, the Big Bang's leftover buzz, echoing from 8 billion years ago. It's a snapshot of the cosmos as a baby, a messy sprawl of hot and cold spots splattered across the sky. Scientists love it. It's random, chaotic, exactly what you'd expect from a universe born in a bang. But in 2005, someone spotted a pattern, a line slicing through it, way too neat to be chance. They called it the axis of evil, and here's the creepy part. It lines up with our solar system like a cosmic arrow. Random fluke? Or is the universe winking at us? Let's tune in and listen to this eerie signal. This starts with the CMB, cosmic microwave background, the glow from when the universe was just 380,000 years old. Back then, it was a hot soup. Protons, electrons, light, too dense for photons to escape. Then it cooled, atoms formed, and light broke free, stretching as space grew into this faint microwave hum we catch today. In 2001, the WMAP satellite, Wilkinson Microwave Anisotropy Probe, maps it, painting a speckled sky of temperature wiggles millionths of a Kelvin apart. It's the Big Bang's fingerprint, quantum hiccups from the start, stretched across billions of light years. Perfect chaos, right? Wrong. In 2005, astronomers Kate Land and João Maguejo stare at the data and go, wait a sec, what's this? They find a line, an axis, cutting through the CMB's low multipole modes, the big, smooth waves in the pattern. It's subtle, tiny dips and peaks, like ripples in a pond, but it's there, and it's weirdly aligned with our solar system's ecliptic, the plane where Earth and the planets orbit the sun. They dub it the axis of evil, not because it's sinister, but because it's a cosmic middle finger to our models. The CMB should be isotropic, same in every direction, no favorites. This axis says nope, something's up. It's like finding a straight line in a Jackson Pollock painting. Cool, but freaky. So what's causing it? Option 1. It's us. Earth's zipping through space at 370 kilometers per second around the sun, and the sun's hauling us around the galaxy. That motion could Doppler shift the CMB, smudging it, or dust in our solar system, zodiacal light, might scatter it, faking a pattern. In 2007, MAPS team cleans the data, scrubs out motion, dust, everything. The axis. Still there, stubborn as a stain. Option 2. It's real, baked into the universe. Maybe the Big Bang wasn't uniform. Some early twist or squeeze left a mark. But that breaks cosmology's rulebook. Space should be even, no cosmic graffiti. Here's where it gets eerie. That alignment, it's not just with the ecliptic, but close to the equinoxes, where day equals night. The odds? 1 in 1,000, maybe less. In 2013, the Planck satellite, MAPS' sharper cousin, remaps it. The axis fades a bit, fuzzier, but it's still there, taunting us. Could it be inflation? That wild stretch post-bang went lopsided, etching this line? Or, stay with me, is the universe finite? A funky shape looping back, aligning by chance? Picture it, a cosmic arrow, pointing at us, etched in the oldest light we know. Let's zoom in. The CMB's cold, too. 725 Kelvin, just above absolute zero, everywhere. Those spots, millionths of a degree off, seeds of galaxies. The axis of evil is in the big waves, low multipoles, scales spanning half the sky. It's faint, microkelvins, but precise. Fun fact, WMAP flew 1,000,000 miles out to Lagrange Point 2, away from Earth's noise, just to hear this hum. And there it is, a line in the chaos, like someone drew it with a ruler. Okay, let's play a game. You're staring at the CMB, speckles everywhere, a cosmic snowstorm. Then you spot it, a faint axis, slicing through, matching your orbit. Is it a trick? Scientists nod, probably motion, dust, a fluke. Fine, but what if it's not? What if the universe tagged us, Earth, the solar system, in its baby photo? Planck's 2018 data softens it. Less evil, more whisper, but it won't die. Every ripple we map, every tweak we make, dances around this line. Here's the creepy bit. It's been there 8 billion years. Before stars, planets, us. That alignment. It's like the universe knew we'd show up, orbiting right along it. In 2025, new CMB experiments, Simon's Observatory, maybe Lightbird, might sharpen it. Could be noise. Statistics love a good prank. Or, wild thought, is it a signal? Not aliens, but physics we don't get. Multiverses, a cosmic frame we're stuck in. Imagine the CMB as a canvas, and someone, or something, scribbled a note. Let's break it down. The CMB's our best shot at the Big Bang. Pure, ancient, untouched. It's random, models demanded. The axis of evil? It's a glitch, or a clue. Scientists lean fluke, clean the data, and it's faint. But that solar system link, it's too close. Picture standing in a storm, raindrops random, then a line forms, pointing at you. Coincidence? Sure. Unsettling? You bet. Every telescope we build, every map we refine, might erase it, or make it scream. So tonight, as you drift off, imagine that hum. The CMB's static, 8 billion years old, washing over you. It's chaos, sure, but there's that axis, faint, evil, aligned with us. Is it noise? A trick of the sky? Or, here's the chill, did the universe draw a line, just for us? Sleep tight, if you dare. or listen for what's humming back. The zone of silence. Imagine you're driving through the desert, sand stretching out, sun blazing, your radio blaring your favorite tune. Suddenly, the music cuts out, static, then nothing. You fiddle with the dial, dead. Your compass? Spinning like a top. Your phone? No bars. Welcome to the zone of silence, a patch of Mexican desert where signals go to die. It's real, not some sci-fi flick. And since the 70s, it's been baffling everyone from truckers to scientists. Is it just a magnetic quirk? Or, here's the creepy part. Does this place have a mind of its own? A cosmic dead zone reaching out from the stars? Let's walk into the silence and see what's whispering or not. This all kicks off in northern Mexico, near the borders of Durango, Chihuahua, and Coahuila, 26 degrees north, right on the Tropic of Cancer. It's a flat, dusty sprawl, scrubby plants, rocky hills, the kind of place you'd speed through without a second glance. Locals call it the Zona del Silencio, and it's about 50 kilometers wide, a quiet circle in a noisy world. The legend starts in 1970, when a Athena rocket goes haywire mid-test, veering off course from White Sands, New Mexico, and crashing smack in the zone. NASA scrambles in, expecting a quick recovery, but their radios? Useless. Compasses? Wild. The story spreads. Something's off here. And it's not just bad luck. What's the deal? Step 1. Test it. Locals swear radios fade. AM, FM, CB, you name it. Right at the edge. Compasses spin, pointing anywhere but north. In the 80s, Mexican scientists roll in with gear, magnetometers, signal detectors, and confirm it. Magnetic fields here are wonky, stronger than they should be. Iron deposits underground, magnetite, hematite, could mess with things, bending compass needles like a funhouse mirror. Radio waves? They drop out, like someone flipped a switch. It's not total, some signals squeak through, but it's enough to make you blink. Fun fact, the zone's near the Mapamai Biosphere Reserve, a hotspot for weird rocks and rare critters, adding to the vibe. So, Theory 1. It's geology. The area is loaded with iron-rich meteorites, chunks from space that slammed down eons ago. In 1969, a meteorite dubbed Allende crashed nearby, scattering bits packed with magnetic goodies. Maybe the zone's a cosmic scrapyard. Its ground juiced with enough iron to scramble signals. Magnetic fields here clock higher, sometimes double the norm, bending needles and swallowing waves. Cool, right? But it's spotty. 50 kilometers isn't a clean circle, and signals fade in patches. Shouldn't it be smoother if it's just rocks? Theory 2. The sky's in on it. The zone sits under a geomagnetic quirk, near the Tropic of Cancer, or solar wind. That stream of charged particles from the sun might funnel oddly. Picture it. Solar storms hitting Earth's magnetic shield, warping local fields. In 2011, a solar flare spikes, and reports from the zone go wild. Radios dead, compasses dancing. Scientists nod. Geomagnetic anomalies could amplify the mess, especially during sunspots. But it's not constant. Solar cycles peak every 11 years, and the zone's quiet all the time. Here's where it gets eerie. Locals don't just talk science. They've got stories. UFOs hovering, lights in the sky, voices from nowhere. In 74, a rancher swears a glowing orb lands, leaving scorch marks. Unexplained, still there. Meteorites fall here more, way more, than stats predict. In 2023, a small one hits, tracked by the Mexican Space Agency, right in the zone. Coincidence? Maybe, but it's like the place is a magnet, not just for iron, but for strangeness. What if it's not just Earth? What if, stay with me, cosmic forces converge here, a dead zone tied to the stars? Let's zoom in. You're standing there, sand crunching, air still. Your radio's a brick, 100 watts, silent. Your compass spins like it's drunk, north's a guess. Phones. Forget it. No 4G, no GPS. Scientists clock magnetic spikes, 50 microteslas, double the usual 25. Radio signals at 100 megahertz? They fade, absorbed or bent. Fun fact, the zone's near the 104th meridian west, aligning with odd magnetic quirks globally, like Bermuda's cousin. Picture it, 50 kilometers of quiet, a bubble Okay, let's play a game. You're a scientist, gear in hand, stepping in. Radios die, check. Compass flops, yep. Is it iron? You nod. Magnetite's a beast, twisting fields. Fine, but what about those lights? Ranchers swear they've seen glowing orbs, no sound. Solar wind? Sure, charged particles could spark it, but that meteorite rain, it's too frequent. Imagine the zone's a trap, cosmic debris snagged, signals snuffed. Scientists scoff. Geology, weather done. But that silence, it's heavy, like the desert's holding its breath. Here's the creepy bit. It's been quiet forever, long before radios, before us. The Chichimeca people knew it, called it sacred, avoided it. In 2024, new magnetometers map it. Fields shift, unpredictable. Maybe it's Earth, iron and sun, a natural mute button. Or, wild thought, is it a cosmic glitch? A spot where space leans in, drowning our noise. Picture standing there, tech dead, stars blazing. Something's pulling, meteors, fields, maybe more. Let's break it down. Magnetite's real, tons of it, measurable. Solar wind's a player, flares spike the chaos. But that UFO chatter, those crashes, it's too much. In 2025, a Mexican team plans drones, high-altitude signal tests. Could be geology, iron's a signal killer. Or, stay with me, a stellar spotlight, a dead zone tied to the void. Every test we run, every wave we send, hits that wall. So tonight, as you drift off, imagine that zone. Sand glowing under stars, silence swallowing sound. It's Earth, sure, but there's a strangeness to it. Is it rocks? Solar tricks? Or, here's the chill, does it reach beyond a cosmic mute with a mind? Sleep tight, if you can, or listen to the quiet pressing in.